Good morning, everyone. In this class, we will be discussing a few problems related to defibrillator. The first problem could be how to calculate the energy which is stored in the capacitor. Okay, so we know what is the main purpose of defibrillator. Inside defibrillator, we have the main component, that is a capacitor. That capacitor will be storing the energy based on its capacitance value, and then it will be releasing the energy whenever it's been required. Okay, so the patient to patient or application to application, the energy is being delivered to the patient, or it will be varied, right? So we have to design in such a way based on the demand or application. Therefore that we should know what is the capacitance of the capacitor, so that it will we will get to know what is the energy will be get stored in the capacitor. Okay, so for that we have one formula, that is U is equal to of CV square. So here the U is nothing but it's energy, and C is nothing but is the capacitance of the capacitor, and V is nothing but it's a voltage. So these are the variable. If you substitute the value of capacitance and voltage, then we come to know what is the energy stored in that capacitor. Okay, so here I have given one example to calculate the energy which is stored in the 16 mu of capacitance when the capacitor is charged to 5000 voltage. Okay, so here the given data, you have a capacitor value and then a voltage value. When you apply these two values in this formula in the place of C and V, we come to know what is the energy. Okay, what is the energy will be stored in the capacitance. This is a one kind of formula problem through which we come to know the capacitance, that is the capacity of the capacitor, how much energy is being stored inside. Okay, so based on that only we have to choose the capacitor value. Either we can go with the 16 mu f, or we need a more than that 20 or 50 mu f, or if it is less than this can also be used. Like that only we come to know, by calculating this values. Okay, so next problem will be how to calculate the actual energy is getting to the patient. Okay, the reason is that so whatever value we are fixing, okay, either 200 joules or 300 joules, the same 100 percentage of actual value will not be delivered to the patient. The reason is that when it's traveling through all this way, all this path, there will be some energy drop at each and every parts. Okay, so let's see what are those resistance constriction, so that the energy is getting dropped, and what will be the actual energy is delivered to the patient. Okay, for example, if we are setting 200 joule, the energy delivered to the patient is not exact same as 2200 joules. It would be like 180 or 190 something. The reason is that, as I said before, there will be some resistance through when it's traveling through his paths, so that there will be some energy drop occur at each and every resistance path. Okay, so let's see what is that different types of resistance should consider when we designing or when we setting or choosing the energy. Okay, so actually we have four set of resistance we have to be considered. One is like internal defibrillator resistance. The defibrillator device itself, it has its own resistance. So when its energy is coming out of defibrillator, it has to pass this resistance, so there will be some energy drop occur while it crossing. That will be the first resistance. The second resistance will be the electrodes. You will be placing two pedals, right, over the chest when you are delivering the energy. So that pedal, here we used to say electrode in name of pedal. That pedal will be having some electrode some resistance. That's why it is called electrode resistance, since we are using two set of electrodes. So we will be having two electrode resistance. One is here and another one is here, and one more resistance also there, that is the thorax part, where we are going to apply that resistance. Okay, we apply the energy. If you are placing over the chest, that is the thorax part, that skin, okay, the skin lying under this electrode will also have some resistance property. So when crossing this resistance, there will be again some energy drop occur. So So whatever value we are setting, actually 200 joules, by the time it reaching to the actual targeted area, the heart, yeah, there will be the four resistance. So four kind of energy drop will occur. So that at the end you will be having lesser than actual energy settings. Okay, so we have to think in this aspects, and we have to select what is the we have to select the energy joules, so that the actual outcome will occur. Okay, so if you want 200 joules in the patient end, means we have to set above the 200 joules, so that only at least 200 volts will be getting delivered to the patient. So how can we calculate this thing, what actual energy is getting delivered after bypassing, I mean after calculating all these kind of resistance? That is another very big question mark. So to calculate this thing, we have one formula. Okay, so that formula could be Wt is equal to Rt divided by Rd plus 2Re plus Rt into Wd. So this is the formula to calculate what is the energy absorbed by each and every resistance. Okay, when you are applying all the values in this, okay, we will come to know what is the actual energy is being delivered to the patient. Let's see one formula related to this. So defibrillator has here the first formula, first example is a defibrillator has an available energy Wa of 200 joules. Okay, that is the actual value we are setting in the machine, that is Wa is 200 joules. For example, if the thorax resistance is 40 ohms, electrode skin resistance of paddle, that is the electrode resistance is 30 ohms, and internal defibrillator is 10 ohms. If 10 ohms, if 10 ohms. So in this case, what could be the energies being delivered to the patient? Okay, so you know already what is the formula to calculate the actual energy it's being delivered to the patient. So that you have all the datas, the input given input in the question itself, you have collected all the given datas, like you know now thoracic resistance value, electrode resistance values, and also defibrillator resistance value, and also you have and energy joules also. So when you substitute all this value in this formula, that is the energy, the Wt is nothing but its energy is being delivered to the thorax part. So for that we have to substitute all the values here. The Rt is the thoracic resistance, and 2R is nothing but electrode resistance, Rd is the defibrillator resistance, and Wd is the setting value of defibrillator energy. So when you substitute all these values, you come to know what is the actual energy is being delivered to the patient. So this how we have to calculate the energy what is required for the patient. Based on that, we have to set the input values. Okay, so thank you. In next class we will be discuss next topic.